Every episode so far has been about something Postgres does that you don't see. This one is about the command that lets you see it. If you learn nothing else from this series, learn this. When a query is slow, explain analyze is the first thing you type. Not add an index, not increase memory. That command run against the slow query is the difference between guessing and knowing. Explain and explain analyze are the two commands to know. Both prefix a query. Explain shows you the plan the planner would use, the choice from last episode, without actually running the query. Explain analyze goes further. It actually runs the query and shows you the plan alongside real timings and real row counts. Explain is fast and safe. Explain analyze executes for real, which means it takes as long as the query does, and, worth knowing, for an update or delete, it will actually modify data. Most of the time you want explain analyze on a select. In a transaction, you'll roll back if you're paranoid. The output looks intimidating on first sight. It isn't. It's a tree printed sideways with indentation instead of lines. The root of the tree, the final result of your query, is at the top. Its children, the operations that fed into it, are indented below. Their children below them. Read it inside out. The most indented lines run first, then bubble up. Every line in the plan is a node, one operation Postgres performed. Each node comes with a set of numbers in parentheses. This is where people freeze up because there are 2 rows of numbers per node and both look important. They are, but they mean completely different things, and telling them apart is most of the skill. The first row is the planner's estimate made before the query ran. It has 3 parts. There's a startup cost, an abstract number, not a time, representing how much work happens before the first row can be produced. There's a total cost, how much work by the time the last row is produced, and there's an estimated row count, how many rows the planner thinks this node will output. Those cost numbers are in arbitrary units, not seconds, so their absolute value doesn't matter. What matters is how they compare between plans. The second row, only present with explain analyze, is what actually happened. It has an actual time range in milliseconds, startup and total, real this time, and an actual row count. So for every node, you get what the planner expected and what really occurred. A single plan node zoomed in with 2 labeled rows. Top, planner estimate, cost plus expected rows. Bottom, actual, time plus actual rows, captioned, compare these two. Here is the single most important thing in the whole explain output, and if you take one habit from this episode, take this one. Compare estimated rows to actual rows on every node. If the planner thought a node would return 10 rows and it actually returned 10,000, everything the planner decided above that node in the tree was based on a lie. It picked a nested loop join thinking the inner side would be small, but the inner side was 1,000 times bigger than expected, so that cheap join is now doing 100 million comparisons. The plan looks reasonable line by line and is catastrophic in aggregate because one number at the bottom was wrong and every choice above it inherited the mistake. This is the fingerprint of the stale statistics problem from episode 3. When you see estimated and actual disagree by a large factor, 100 times, 1,000 times, the almost never fix is rewrite the query. It's analyze the table so the planner has current information and recheck the plan. A plan tree with one node highlighted red, labeled rows, 10 estimated, 10,000 actual, with an arrow up to the parent node showing a wildly wrong join choice, captioned, one bad estimate poisons everything above. Beyond that one number, a few other things in the output are worth naming because you'll see them constantly and they mean specific things. Loops. If a node was executed multiple times as part of the plan, inside a nested loop, for instance, the timings and row counts shown are per execution, and the loop count is displayed separately. To get the total time this node contributed, you multiply. It's the most common source of misreading a plan. A node showing 0.02 milliseconds actually ran 100,000 times, cost you 2 full seconds. Buffers. If you run explain analyze, buffers, each node also tells you how many pages it read from memory versus how many it had to fetch from disk. Shared hit is a page found in Postgres' cache. Shared read is a page that had to come from storage. A plan with lots of shared reads is bottlenecked on I/O, and no query rewrite will fix it. You're either short on memory or short on disk speed. Rows removed by filter. This one is quietly damning. It tells you how many rows a node had to look at and discard to produce its output. If a filter step reads 1,000,000 rows and returns 1,000, that number reads rows removed by filter 999,000. Postgres just did a lot of work to throw away a lot of data. Usually assign an index on the filter column would let those million rows be skipped entirely. Now, the practical workflow, because reading a plan is a skill best learned by doing it in the right order, rather than staring at everything at once. Run explain analyze on the slow query. Find the node with the largest actual time. That's where the query is spending itself. On that node, check whether estimated and actual rows agree. If they don't, statistics is your problem, and analyze is your first fix. If they do agree, but the node is still expensive, look at what kind of node it is. A sequential scan on a huge table with a small filter is asking for an index. A nested loop where the inner side is large is asking for a hash join or a merge join, which the planner would pick if it thought the inner side was large. Bringing you back to the estimate question. A sort step spilling to disk is asking for more work mem. Each fingerprint has a specific fix, and the plan tells you which fingerprint you're looking at. A short decision flow. Slow query, explain analyze, find slowest node, check rows estimate versus actual, mismatched, analyze, matched, inspect node type. One habit worth building. When something is fast, run explain analyze anyway, save the plan. That way when it gets slow next month, you have a known good plan to compare against, and the diff between them tells you exactly what changed. In a way, the query is slow now, never will. That's the whole tool. Postgres already knows what it did with your query and why. Explain analyze is you asking, and the single number worth almost more than all the others put together is on every node in the tree, what the planner expected against what actually happened. Explain equals plan, explain analyze equals plan plus reality, compare estimated rows versus actual rows, find slowest node first, save fast plans for later. Next time, what happens when two users click buy on the last item at the same instant? The mechanism Postgres uses to keep the answer correct is the same MVCC from episode 1, but now you'll see it working in real time, with locks, with isolation levels, and with the surprising sharp edges that come out only when many things happen at once.